A conducting ball of radius 3r having charge q is at a great distance from a neutral conducting ball of radius r. They are connected with a thin, perfectly conducting wire of inductance L through a switch. What will be the maximum current in the wire after the switch is closed? So the potential of this sphere initially is kq by 3r and potential of this sphere is 0 initially. Now this is at higher potential, we know this is at lower potential, so the current will flow from higher potential to lower potential. Okay, so we can write the KVL equation, that is potential of this sphere, that is VL at any time t, minus LdI by dt, okay, potential drop across this inductor, is equals to Vs, that is the potential of this smaller sphere at any time t. So we can write the potential of this larger sphere as k multiplied by charge on this sphere. Now let us suppose small q charge यहाँ से कम हो गया and वो इस पर आ गया. So we can write this k capital Q minus small q by 3r minus k small q by r is equals to LdI by dt. So on some rearranging some terms, okay, we'll get this differential equation, that is minus 4k by 3rl minus q by 4 plus small q. Now we can assume this quantity is equals to x and is equals to d2q by dt2y, because हमने di by dt को, we can write this di by dt as d2q by dt2. Okay, and now we can differentiate this equation. It will become dx by dt is equals to d small q by dt. इसको दोबारा differentiate करेंगे, we'll get d2q by dt is equals to d2x by dt2, and we know this quantity is x, तो हमारे पास एक differential equation आ जाएगी, that is d2x by dt2 plus 4k by 3rl into x is equals to 0. Now we can assume this is equals to omega square, and our differential equation will be equals to d2x by dt2 plus omega square x is equals to 0. Okay, now this differential equation is exactly similar to the differential equation of motion of one dimensional simple harmonic oscillator. Okay, and so we can find its solution easily. Okay, so and solution of this differential equation will be equals to x is equals to a sine omega t plus 5, where a is the amplitude of this equation and this is phase. Okay, and remember this is a second order linear differential equation with constant coefficients omega square. Okay, now we can write this x is equals to small q minus capital Q by 4 is equals to a sine omega t plus 5. अब हमको बस a और इसकी वैल्यू निकालनी है, this value, its value. Okay, so we can write this small q is equals to q by 4 plus a sine omega t plus 5, and differentiating this q will get current in the conducting wire. Okay, and we know initially current is 0 at time t is equal to 0, current 0 tha. Okay, and this will be equal to 0, so from here we'll get the phi is equals to pi by 2. Okay, and on substituting this value of phi in this equation, we'll get q by 4 capital Q by 4 plus a sine omega t plus pi by 2. We can write this equals to cos omega t. Okay, so we know at t is equals to 0 charge small q is 0. Okay, small q charge 0 hoga, so from here we'll get the value of a minus q by 4 is equals to minus q by 4. Now we can just put the value of this minus q by 4 in this equation, this value of a, and this small q will be equals to q by 4 ब्रैकेट में 1 माइनस कॉस ओमेगा टी, एंड इसको हम डिफरेंशिएट करेंगे दोबारा ताकि हमारे पास करंट आ जाए जो कंडक्टिंग वायर में फ्लो कर रहा है. सो इट विल बी इक्वल्स टू q by 4 ओमेगा sin ओमेगा टी. नाउ वी नो करंट मैक्सिमम होगा जब sin ओमेगा टी वाली टर्म मैक्सिमम होगी, सो वी कैन राइट इजीली I max is equals to q by 4 अंडर रूट 4k by 3rl, एंड जैसे हम k की वैल्यू को 1 by 4 pi epsilon naught लिखेंगे, द करंट maximum current in the conducting wire will be equals to q by 4 under root 1 by 3 pi epsilon naught